Hello everyone, welcome back to Clear Creek Solutions instructional videos. Today we're going more into some of the soil erosion and sedimentation and construction pollution plans and mitigation methods. We're on part 2 of the series. Now we're going into soil erosion and sedimentation impacts. So let's start right now. So soil erosion and sedimentation caused by land development impact the environment, damaging aquatic and recreational resources, as well as affecting aesthetic qualities. Erosion and sedimentation ultimately affect everyone. Common examples of soil erosion and sedimentation impacts are as follows. We've got natural, nutrient-rich topsoils erode. Reestablishing vegetation is difficult without applying soil amendments and fertilizer. Silt fills culverts and storm drains, decreasing capacities and increasing flooding and maintenance frequency. Detention facilities fill rapidly with sediment, decreasing storage capacity and increasing flooding. Sediment clogs infiltration devices, causing failure, and then sediment causes obstructions in streams and harbors, requiring dredging to restore navigability. Shallow areas in lakes from rapidly resulting in growth of aquatic plants and reduced usability. Nutrient loading from phosphorus and nitrogen attached to soil particles are transported to lakes and streams, causing a change in the water pH, algal blooms, and oxygen depletion, leading to eutrophication and fish kills. Water treatment for domestic uses becomes more difficult and costly. Turbid water replaces aesthetically pleasing, clear water in streams and lakes. Eroded soil particles decrease the viability of macroinvertebrates and food chain organisms, impair the feeding ability of aquatic animals, clog gill passages of fish, and reduce photosynthesis. Sediment clogged gravel diminishes fish spawning and can smother eggs or young fry. So there's obviously a lot of negative impacts to too much soil erosion. That's why when we model using minimum requirements that we went over before, we want to reduce that range of erosive flows. That's why we use a software like wwhm 2012, which allows us to simulate the existing condition using detention facilities and reduce that amount of dangerous erosion for all these reasons that we've outlined here. Costs associated with these impacts may be obvious or subtle. Some are difficult to quantify, such as the loss of aesthetic values or recreational opportunities. Restoration and management of a single lake can cost millions of dollars, and reductions in spawning habitat and subsequent reduction in salmon and trout production and other wildlife cause economic losses to sport fisheries, traditional Native American fisheries, and the fishing industry. The maintenance costs of man-made structures and harbors are readily quantifiable. Citizens pay repeatedly for these avoidable costs in their tax dollars. So not only are there environmental impacts, there's also economic impacts as well. Effective erosion and sediment control practices on construction sites can greatly reduce undesirable environmental impacts and costs. Being aware of the erosion and sedimentation process is helpful in understanding the role of construction stormwater BMPs in controlling stormwater runoff. So now we get to part 2, construction stormwater pollution prevention plans. So now we're going to finally get into these stormwater pollution prevention plans, because while the construction site is being used and activate or being built on, that's when the soils are most vulnerable to erosion during large storm events. A construction stormwater pollution prevention plan is a written document containing text and drawings to implement measures to identify, prevent, and control contamination of stormwater from construction sites. The construction stormwater prevention plan explains and illustrates the measures, usually in the form of best management practices, BMPs, to implement on a construction site to control potential pollution problems. While it's a good idea to include standards and specifications from the construction SWPPP and the contract documents, the construction SWPPP should be a separate document that can stand alone. As site work progresses, the construction SWPPP must be reviewed and modified routinely in prescribed time periods to reflect changing site conditions, subject to the rules for plan modification in the Construction Stormwater General Permit and/or the local permitting authority. A construction pollution prevention plan is required if one of the following applies. The construction project must have coverage under the Construction Stormwater General Permit, see 1-27 Construction Stormwater General Permit. The construction project is located in a municipality covered under one of the following municipal stormwater permits and meets the thresholds for requiring a construction SWPPP in the permit. Phase 1, Western Washington Phase 2. The local permitting authority requires a construction SWPPP. Check with the jurisdiction about local requirements related to construction stormwater. Ecology and/or the local permitting authority determine the project site or facility to be a significant contributor of pollutants to waters of the state. The owner or lessee of the land being developed is responsible for preparing the construction SWPPP and submitting it to local authorities. The owner or lessee may designate someone, that is an engineer, architect, contractor, to prepare the construction plan, but the owner retains the ultimate responsibility for environmental protection at the site. An engineer is required when proposed BMPs require design calculations such as temporary detention ponds or ditch sizing. The construction plan narrative must be located on the construction site or within reasonable access to the site for construction and inspection personnel. A copy of the construction plan drawings must be kept on the construction site at all times. So this section presents what you should consider when preparing a construction plan, as well as what you should include in the construction plan documents. Local permitting authorities may allow small construction projects to prepare a simpler construction plan consisting of a checklist and drawings. Designers should check with the local permitting authority about local requirements for construction plans. On construction sites that discharge to surface water, the primary concern in the preparation of the construction plan is compliance with Washington State water quality standards. On construction sites that infiltrate all stormwater runoff, the primary concern in the preparation of the construction plan is the protection of the infiltration facilities from fine sediments during the construction phase and protection of groundwater from other pollutants. Several of the other elements are very important at these sites as well, such as marking the clear limits, establishing the construction access, and managing the project. So each of the 13 elements identified in 1-342, minimum requirement number 2, construction stormwater pollution prevention plan, must be considered and included in the plan unless site conditions rendered the element unnecessary and the exemption from that element is clearly justified in the narrative of the plan. Hydrology has prepared the following tools for use as you prepare the plan. The construction plan template available at the link down below. So go to that link if you want a plan template. Remember, this is all pulled from the Washington State Department of Ecology Manual. Okay, that's what all this information is from, and I suggest you go check that out if you want the absolute direct source from that. That's where we're getting this information. The customizable template presents the recommended structure and content for the construction plan checklist, and then the plan checklist PDF download. This checklist is a quick reference to help determine if all the major items are included in the construction plan. So here are some of the steps. Step 1, research site conditions. Consider and research the following site-specific factors to understand the site-specific construction stormwater pollution prevention needs. Topography. Consider the topography of the site. The primary topographic considerations are slope steepness and length. Steeper and longer slopes have greater erosion potential than do flat and short slopes. A licensed engineer in the state of Washington, soil professional, or certified erosion control specialist should determine erosion potential. Then drainage. Identify existing drainage patterns including swales, ditches, storm drain pipe systems, etc. Plan to convey runoff through the natural drainage patterns that consist of overland flows, swales, and depressions to avoid constructing an artificial drainage system. Properly stabilize man-made ditches and waterways so that they do not create erosion problems. Ensure that increased runoff from the site will not erode or flood the existing natural drainage system. Consider possible sites for temporary stormwater retention and detention. Direct construction away from areas with saturated soil where you may encounter groundwater and away from critical areas where drainage may concentrate. Preserve natural drainage patterns on the site. Then for soils, identify soil types and erodibility, low, medium, high, or an index value on the site, and then evaluate the soil properties such as impermeable layer, depth, shrink swell potential, etc. Express these qualities in average or nominal terms for the site. This information is often available in published literature by qualified soil professionals or engineers. For example, the 1983 Soil Survey of Snohomish County lists the following information for each soil mapping unit or designation: a sieve analysis of the soil, permeability, available water holding capacity, and the percent of organic matter. Soil information can be obtained from the NRCS manual if one has been published for the county containing the site, or the NRCS Web Soil Survey website, which you can find the link here. Additionally, soil data can be obtained through site soil analysis as part of the preparation of a stormwater site plan. Ground cover, identify features such as trees, clusters, grassy areas, and unique or sensitive vegetation. Unique vegetation may include existing trees above a given diameter. Ground cover is the most important factor in terms of preventing erosion. Saving existing vegetation will prevent erosion better than constructing a BMP. Trees and other vegetation protect the soil structure. If you cannot save the existing vegetation, consider such practices as phasing construction, temporary seeding, and mulching. Phasing construction involves stabilizing one part of the site before disturbing another, and this way the entire site is not disturbed at once. Then critical areas. Identify critical areas adjacent to or within the site. Critical areas may include flood hazard areas, mine hazard areas, slide hazard areas, etc. Any critical areas within or adjacent to the site should exert a strong influence on the land development decisions. Only unavoidable work should take place within critical areas and their buffers. Such unavoidable work will require special BMPs, permit restrictions, and mitigation plans documented routinely in the construction SWPPP. Then adjacent areas. Identify existing buildings, roads, and facilities adjacent to or within the site. Prepare to identify existing and proposed utility locations, construction clearing limits, and erosion and sediment control BMPs on the drawings. The analysis of adjacent properties should focus on areas both upslope and downslope from the construction project. Water bodies that will receive direct runoff from the site are a major concern. Evaluate the types, values, sensitivities of, and risks to downstream resources such as private property, stormwater facilities, public infrastructure, or aquatic systems. Then existing encumbrances. Identify wells, existing and abandoned septic drain fields, utilities, easements, setbacks, and site constraints. Precipitation records. Determine the average monthly rainfall and rainfall intensity for the required designed storm events. These records may be available from the local permitting agency. You may also refer to Appendix 3B, isopluvial maps for design storms, and Appendix 3C, rainfall amounts and statistics to help determine rainfall patterns at your site. Then timing of the project. Consider the timing and duration of the project when selecting BMPs. Projects that will proceed during the wet season and projects that will last through several seasons may take all necessary precautions to remain in compliance with the water quality standards. Okay, so that was 2.2. Now we're going to get into 2.3 about construction stormwater BMPs. So thank you for watching this video. We'll see you guys in the next part.